Welcome to classwork 2.2. Today we're going to talk about graphing and transformations. So the first thing we got to do is graph this 1 over x. This is going to be a pivotal parent graph. So essentially this is something you should memorize. Hopefully you recall it from Algebra 2A or 1C. Either way, at this point you definitely need to memorize this graph. It looks something like this. There's a point at 1, 1, a point at negative 1, negative 1, and then there are vertical asymptotes, or a vertical asymptote at 0, and a horizontal asymptote at 0 as well. And then from there, you can kind of just estimate it. These are called like little hyperbolas, but essentially they're like little curves approaching your asymptotes on each side like that. That's your parent graph you absolutely must know. And we can actually do the domain and range here. The domain would be everything except for 0, and the range would be everything except for 0 as well. And just to be clear, we'll state our VA and HA. Our VA is x equals 0. Our HA is also y equals 0. So there's our complete graph. And again, the 2 points you absolutely must know: 1, 1, negative 1, negative 1. And then from there, you just kind of estimate the graph. Now, on the iPad, graphing is actually pretty cool because we can actually just use our iPad tools to graph this. So first, let's just know what's happening. The parent graph is 1 over x. So let's analyze what's happening here. There's a stretch factor of 2, so write y times 2. It's going to reflect over the x-axis because of that negative there, so just write reflect over x-axis. And then it's going to move right 1 and up 3. Now this is why the iPad's pretty cool, because I can just grab this thing right here. I'm going to copy it. And I can just place it right here. So right there, there's my parent graph. Okay, so now we can just apply everything. It says y times 2. So I'm just going to erase over here. So 1, 1 simply will become 1, 2, like that. So this other one should be negative 1, negative 2. So notice how we can just correct that right there. And now we can kind of sketch it. So same thing, still approach your asymptotes. We just have a slightly stretched out graph. So now step number 1 is done. We have done y times 2. From here we want to reflect it. So we're going to reflect over the x-axis. So look what we have here. Let's just reflect it. So we have 1, 2. That becomes 1, negative 2. The other one is negative 1, negative 2. So that would be up here. And just draw it out. Something like that. So now we can get rid of the blue one. And now we're going to move it right 1, up 3. So let's grab it, carefully move it right 1, up 3. Right 1, 1, 2, 3. And there's our graph. Pretty cool. Let's label the new points. 0, 5, 2, 1. And I can see I have my VA at x equals 1, my HA at y equals 3. And there's a complete graph. We can also do domain and range. The domain is going to be all x such that x cannot be 1. And the range, that's going to be all y such that y cannot be 3. And that's it. Graphing, no problem. Now you also notice something cool here. Look at this VA, x equals 1. Notice how that's directly related to right here. And the HA is directly related to right there. Look at that. HA is actually in the problem, and so is your vertical asymptote. So that's pretty cool. Our next graph to talk about is 1 over x squared. You probably covered this last year, but I just want to refresh your memory. Some people call it the volcano graph because it kind of looks like a volcano. It looks something like that. The points you have to know are going to be 1, 1, negative 1, 1. So again, those are the points you must know. The asymptotes are the same as the other graph. So just draw it out like that. And then from there, exact same thing. Draw your curves and make sure they approach your asymptotes like that. And there's our rough sketch. We'll do the domain and range. The domain is what you'd expect. It's pretty similar to the last one. Everything except for 0. But the range is a little bit different. The range, notice how there's nothing down here. So we just have to write y such that y is greater than 0. And of course our VA and HA are x equals 0, y equals 0. And again, this is a parent graph. So you must study that graph and memorize it. But don't worry, you'll use it a lot today, so after today's class it should be in your head. So when we're here, if you see a question like this, all you got to do is think, well, what's happening? The parent graph is 1 over x squared, so we're going to use our graph right there. And I can see there's no stretch, no reflection, so it's just right 2 and up 1. So again, let's just use our iPad. I'm going to grab that, copy. Let's put that right there. And I'm going to get rid of these points because I don't want that right now. We're just going to follow the directions. Right 2, up 1. 1, 2, 1. And look at that. We're done. Our new point is 3, 2. This point is 1, 2. The domain is all x such that x cannot be, that would be 2. And our range is all y such that y is greater than 1. Our VA is x equals 2. And our HA, y equals 1. And again, notice how VA is right there, HA is right there. And that's it.